So that's a full room as well. Good evening, everyone. Thank you very much for taking the time to come and see what we have to talk about. My name is Mark Proctor. I'm an employee of Red Hat. I started the Drools project with a couple of other people, a co-founder, almost like 10 years ago now. I forget the exact dates. We joined JBoss in 2005. 2006 we were acquired. And it's gone from me being the sort of the first hire at JBoss on my own in 2006 to we are now we have sort of merging between rules and processes between that group. There's about 18 of us now after the latest acquisition. So Red Hat are very, very aggressive about the space and pushing hard into it. So my talk today is going to be mostly about what's new in 6.0. So I'm not going to do what's a rule engine, and it's going to be more on the technical side around deployment, around utilisation. That's one of the things we've been fixing. So I just want to have a quick check here. Who doesn't actually know what a rule engine is or doesn't know what Drools is? So everyone here, just you. Sorry. Okay. All right. Well, I have a really quick intro. So depending upon who put their hand up or didn't, I'll do a very quick intro to what a rule engine is, but it won't be much. So this will focus more about what's new and stuff. It's been an absolute nightmare for me because we have Red Hat Summit coming up, and when they were asking me to do this, like I really don't have time, and they're very persuasive. So I also have to do all new content because of what's new. So I literally started this last night, so please bear with me. I've gone through all night, I haven't slept to get this presentation done to come down here. Literally, I have not slept. So it might be a little bit rough in places. There's actually a bit more of an agenda on here. I was just finishing my slides off, so please do bear with me. But I think those who use Drools and have problems with it should find this interesting. And I don't know how long the content's going to take, so we'll see. This will be interesting, even for me as well. So this is going to be the quick intro. Just to try and get people understanding that what we do at the chorus level, what's called knowledge representation and reasoning, it is a core of artificial intelligence. And obviously, if you say that to people, it sort of scares them. So in the business world, we tend to sort of fluff all over that and say, yeah, it's about making decisions. But actually, where this comes from, which I'm going to try and illustrate to you now, it's one of the core areas of artificial intelligence, which everything else builds off of, called knowledge representation and reasoning. It's a fascinating area, and it's one of those things in which, once you get into that field, you can study it for the rest of your life and only scratch the surface. And that's really my field, knowledge representation and reasoning, AI engineer. I just have to make sure I can apply that to the real world and help Red Hat make some money and solve real world problems. But I love the research side. So it started off in the 1970s in what's called clinical decision support systems. That sort of died out in the 80s when the funding dried out. The AI world tends to be very cyclical in its funding. Why do they need to build these systems? Because not everyone is as smart as House. So we needed to have systems that can make people smarter. Charles Forgy in 1979 developed the RITI algorithm, and with that he had the OPS5 rule engine, which kind of revolutionized the world. I don't want to say revolutionized at the extreme, but in that industry it was game-changing because it was able to do sort of reasonable real-time processing, which wasn't available before. And an industry has been built off the back of that. Other notable aspects is Eclipse in 1986. Which is basically sort of an open source version of ART, which is a derivative of OPS5, and also Jest in 1995, which is a derivative of, well, almost a clone of Eclipse. And someday I hope we'll be able to build something like this with what we're working on. So what is a rule? A rule basically is when a condition happens, then do something. But it is not an if statement at a point in time. It is simply when the situation happens, whenever it will do this. There is no indication of flow or before or afters. Rule engine is what's called pattern matching. It's trying to identify things. And here we say this is the object type, this is the field, this is the restriction, and this forms a pattern, and we're pattern matching. I'm not going to get into too much of this. The pattern matching process works in two phases. A rule engine is basically like an in-memory database. And you put your information into your data, you insert it, you update it, and you delete it, and it keeps in this big store. And it matches that data to the rules. And what it does is, after you do all your inserts, update, and deletes, it goes to the agenda, it pops one off. The agenda is, what do I want to do? What am I going to execute? What am I going to fire? Pops one off. That then modifies the data and repeats as this cyclical action. It's very, very simple, actually. So an example, so you can get a better feel for it. For those who've seen my talk, you'll have seen this one many times, but it's a nice, simple example. So you have account, cash flow, account period. To help people understand what's going on, I have an SQL example. I hope you can all see that from the back. And this is very simple. It is a credit SQL. It's saying for a given date range, what are my credits? So Q1, Q2, Q3, get me my credit cash flows. And notice the trigger. So you basically have a view with a trigger. For every cash flow is going to increase, every credit cash flow is going to increase the balance. And then relate this to a rule, the Drools rule language. I'm not going to go into what the rule language is today because this is a what's new, but just trying to give those, if you haven't done it before, some grounding so I'm not completely lost. I've lined that up wrong. But anyway, the account from account there, should, oh no, it is fine actually, is the account here. So there we go. So the account there is the table, and here is the object type. And so from the account, that's account there, and there we go. There's the account period, and that's the account period there. Rule engine had the bindings before, and there has an after. And there's the constraints, the where clause, which is a literal constraint there and the join constraint there. Whereas SQL separates them, so the selection of the types and the selection of constraints are separated. And rule engines are together, so within the cash flow object type are all the constraints encapsulated. There's the literal constraints and there's the date range. We also allow binding of fields as well. You can bind the field or the class. So if you understand SQL, you can understand the rule engine. Just to show the example a little bit more, here is a credit rule, here is a debit rule. The only difference is credit, debit, increase the balance, decrease the balance. If it's Q1, we have 2 credits and 1 debit, and there's a balance of minus 25. If we were to go to Q2, we have a balance of 50, because there's plus 50 there, just the 1. If we wanted to print the balance, it selects the same information. So if you're having a view of information, which one will respond first? So you have a thing called salient, just priority. And the default is 0. The higher the number, the more the priority. So you can see here, this is our agenda, this is the rules. It's like the rows of data that have matched that can fire. And 1, 2, and 3 are arbitrary. Increase the balance, decrease the balance, increase the balance. I don't care the order they fire in, that's fine. Whereas the print balance, I must make sure that prints after all those ones are done. And the salient does that. We also have a thing called rule flow. This is an old diagram actually, where you can orchestrate the same thing with a flow diagram. I have a little video here. I've embedded them rather than doing real demos, showing this exact example. I've just committed to the examples actually. So these are your types. Just showing there's your cash flow, some Java. It's going to go to your DRL, I hope it doesn't go too quickly. You can see it's the rules you've already seen, and then the print rule when it's there with the salience minus 50. This is the cash flow main. It gets the session. It inserts the data, so you can see there's my cash flows. It's Q1. Can I pause this? I'll let it just run again. When you've done the laptop, you actually have the ability to stop and pause and play in the video. I have to wait for it to catch up now. So it's just showing the 3 rules, which you've already seen before. I'll explain it ahead of time now. When it's in the main, it's got 2 phases. First is Q1, so you don't count period. And what it does is it will update just there. So it sets the account to Q2 and updates. So there's the file rules there and there's the file rules there. That's the 2 cycles as we process the cash flows for the 2 different quarters. I run it, and there we go. Balance of minus 25 and balance of 25. You've just witnessed your first reactive rule-based system for decision management. So we've gone through a bit of a change. we started, about 4 or 5 years ago, 2006, we realised that rule engines can't work on their own. So we started to merge in rule engines and workflow engines and event processing engines. And as a result of this, we have a platform now which I'm calling KIE, for short, knowledge is everything. It's actually a new name, it's not something we've introduced yet. It's a project name, not a product name. The product name is still BRMS and Business Central, but at the community level, trying to get a word that references, that relates to everything we're doing. I'm just using the word KIE. It got through corporate branding, they were happy with it, so it's a nice short word. And it basically refers to everything, rules, processes, workflows, agents, all the work we're doing within the community. So here's a little illustration of how this now looks currently with our projects. So you have KIE at the top. You have Drools and JPM, which everyone's aware of. Drools Planner has been renamed to Opta Planner. We have a new project called UberFire, which is part of my talk today. UberFire is our new, we learned a lot from doing our first web UI, and this is us doing it right. And we separated it so that everyone can build their own workbenches now. So what you're going to see today is not just talk about Drools, you can go away and build Drools-like applications. Governor has been separated, so Governor now is a layer on top of UberFire, the workbench, which provides sort of a GIT Base Backend, which I'll talk about in a minute, Maven management, project building. It no longer includes like the editors and stuff. Those are in Drools WB, so decision table, guided editor, those are Drools things, they're not Governor things. Likewise, tasks, BPM flows are in JPM WB. WB stands for workbench. We will have 3 distributions at a project level. This will be one WAR, that'll be another WAR. That's for the Drools-specific WARs, that's for the JPM-specific WARs. And this is the fully integrated version. So this is basically the equivalent of BRMS product. They'll talk about product later on, won't you? Yeah?
Maybe.
Maybe. So this one here is actually equivalent to Business Central. So Business Central, as product-wise, is the amalgamation of all these together. And they will be the 2 product offerings that we have. If you want to get started, get involved, this is the URL in GitHub. That will change. So before we had the name KIE, because the 2 main brands are Drools and JPM, you'll see the words Drools and JPM there. But, that's a bit, we have other projects now, like Opta Planner. We just done a Polymeter acquisition, so we've got their dashboard builder. So that's the other reason for a name change. Something agnostic to show that we're growing the brand to the community level. This is the project you need to check out, which is a bootstrap. And this has, within it, once you check this out, so there's a clone, it has commands you can do which will clone all the others and build all the others to get you started. So we're really focused on trying to make sure that these aren't just individual projects that you're going to struggle to build together, that in theory, if we're doing our job properly, it should be able to build almost the whole kit and caboodle for you. And we have this, on that same website, the wiki page, there's detailed instructions about getting started and how the scripts work. Some of the changes in 6.0, so that's what people are saying, how much is this going to hurt me? So yes, there are changes. As I mentioned before, where you saw the name Drools and JPM, either in a package name, repository name, or wherever, that has now changed to KIE. Anything that has the word knowledge in it, we've also changed to KIE. That's often used as a prefix for some projects and for some class names. The reason why we did it was it signifies a new platform, and it's smaller than knowledge, so it's actually nicer to write. We have, and these are the way the classes look, so that's actually KIE Base, sorry. Stateful knowledge session just becomes KIE session. Stateful knowledge is just states KIE session. We do have a legacy API adapter jar, which we're working on now, so existing projects should work almost completely without any changes, apart from the knowledge agents. That is because the deployment mechanisms have changed. But there should be a work around this because we have a migration tool which will take you from the old package-based deployments to the new jar-based deployment, which I'm going to talk about in a minute. The DRL itself has not changed, we are still compatible there. So I'm going to talk about quickly how we got it all wrong. So critique of the 5 series. Not all wrong, but you learn a lot. What you have to remember with the Drools code base, that much of the code that's been there since 2006, we have kept backwards compatibility in that time. We've never removed any features, so we have layer after layer, kludge after kludge. Other projects seem to rewrite themselves every 3 years. We've evolved, but we've never rewritten, and we've always made sure we have that backwards compatibility. And this is the first time that we're now starting to do a bit of house cleaning, a bit of tidying up. But we're trying to do it very delicately, like having adapter jars, like making sure we've got migration scripts. And this will be an evolving process. And as I say, the last 6 to 9 months, we've been investing in our future to make sure that in our web development, there are a lot of things we got right, but we found that it was not modular enough. And making the changes was becoming too hard. We weren't being responsive enough to business needs. So I'm going to demonstrate a project to you soon, which basically has really enabled our web development to be able to work in a distributed team, to be able to be effective, and to continue to do good modular code. I'll come on to that a bit later on. So yeah, we had GWT, that's not changed, but it was not easy to extend. We had fixed layout. This design here, this panel here, that was it. We had no ability to change that. Now, if you want to start building an integrated system with human tasks, with workflows, with designers, that is not good enough. And it has no perspective. So like in Eclipse, I want to be able to change between different modes. Am I deploying? Am I building? Am I authoring? We need to have a system that's responsive to the way in which the user's working. So that's what we've been working on. The back end, this is one here, it's a little bit... Some people are a bit upset by this. We adopted JCR in 2006. For then it was the right decision. We wanted to be 100% Java. And there was simply no other way of doing this in 100% Java other than JCR, unless we were to write a Hibernate backend ourselves. So JCR was something that worked out of the box, and effectively gave us content versioning and storage with very little work. CBS, SVN, all C-based systems, we don't want to have to go through the JNI hassle when we're trying to get people working out of the box. However, JCR has performance issues. One of the reasons being is that JCR is a graph system. Unlike normal file systems are tree-based. They go in one direction and each folder only has one way to get into it. JCR, the content guys said, oh, well, because it's for content management, for document management. They said, well, this document, there's lots of different ways to get here, and we have to encode all of that. And that's great. But the problem is that that is a very hard performance problem. It's graph-based theory. And that's one of the reasons why JCR has this problem. And what you have here is a feature which maybe only 5 or 10% of people use, which is causing the slowdown. We don't use the graph stuff. You know, so why do we want to pay the impact of the cost of this and the complexity? So that's one reason why I moved away from JCR. And also, everything's stored as a blob. I had some customers like it because it's standard, but actually, other customers who like to get their hands dirty, they want control of the data, they want to be able to know that if something goes wrong, they can fix themselves, they can get it out. I know a very big mortgage company that would not use JCR for that reason because it's stored as a blob. Tagging and branching is not very good, and certainly not scalable. And JCR has limited web dev support. We built an Eclipse team provider, but it always breaks. It's very hard to get working properly. The good thing, I want to tell you that these things have all been fixed, so don't get too upset. Also, we made mistakes on our content that we had a single tree structure, a single set of packages, which means to try and have projects, we had to have a project mapped to a package or a folder. And that's not natural to how developers work. It's not really scalable for having large teams and large number of projects. Packages created as deployed units. So you have this one large tree of these folders, and each folder it becomes a deployment unit. Again, this is very archaic. Nothing else works like this, which means it's not intuitive. It's not easy to reuse rules. We had a global area as a hack to allow a certain amount of resharing, but it wasn't ideal. And the model loading, some of you might remember that you have to upload a model to a package, but if a package is a namespace and a model and a jar has a whole range of namespaces, you've really got an impedance mismatch. You know, it's basically a hack. We're solving business problems, but you can only do so many of these before you have to redesign your system. So deployments. I think I've got a closer to this in a minute. We had a simple snapshot system. Much of the things we built, you remember when we were doing this, there were 3 of us. So also put in perspective that we did a lot for 3 people. And also as well, what we take for granted for Maven-based deployments and how we do things now and good methodologies, we did this back in 2006, but it's still Maven 1. That's what I'm trying to say. We have been living with the legacy choice that we've made, which were probably the right choices at the time. But we're adapting, we're learning, we're improving. So yeah, snapshot deployment basically means at any point we take a produced knowledge base and we compile that into an instance, a bean, and that bean is serializable, what we call a package, and we can serialize that package around, and that forms means you take a snapshot, serialize the package around, and that kind of forms a deployment. There's no real methodology here. It's something that works, it was quick, it was easy, it solved simple problems. It doesn't solve scalable or enterprise problems as well. I mean, we've got fantastic engineers, and they managed to make it work, but you know, it's not. We can do a lot better. So that we've addressed that as well. And obviously, everything we did was API based. It's all about this boilerplate code, having to do this over and 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 over again. It's very boring, and there's again better ways of doing this. So let's start with the UI improvements. So introducing the UberFire project. So we are what we call permissive licensed. The UberFire is a permissive licensed project. You won't have heard of it yet, it's not really officially launched, you're welcome to try it, but it's still going through the final stages. Obviously our priority is to BMS and to BPNS products. So this is a critical thing that we do see that is necessary for our project. But close up. I have a video in it, you'll see in a second. In essence, the screen's not very good here, unfortunately. What you have is an Eclipse-like workbench. Each one of these are views, so you can see you've got the File Explorer here, you've got a little view there, there's a decision table, and there's the problem view. As you do compilation changes, that updates. That's really bad, isn't it? That's a menu system there, just showing you the menu choices. Let's hope the video is better. I'll talk you through it anyway. So, what it's just showing here is moving between projects. So I've got opened up two editors. Watch this, I'm going to drag that down there. And so I actually have ability to customize my displays as I want. Everything works like Eclipse, everything's drag and droppable. Everything's positioned on the page. I'm doing my navigation to my projects. Opening up a test scenario. Test scenario is currently tabbed, but I decided I want to have side-by-side viewing. Bear in mind, I only got a very small screen real estate. It doesn't look great here, but once you, just for this, when you do this in reality, having side-by-side works really well. So again, these are things, this flexibility display did not exist before, and this was really important for us to get this. And also perspective switching. I've just switched to the governor management now. So this is, we have built-in Maven support now for dependency management. I'll come back to that in a minute. You just saw there, switching perspectives, switching back into perspectives, it preserved the layout. Going to the administration, this is where we can clone and do repository management. Everything here is a GIT backend. And you can have as many repositories as you want, as many projects as you want. Everything's Maven based. It will build any Maven project, not just a Drools project. You can clone any Maven project with Java, it will build it and deploy it to its local Maven repository here. I think we're at the end of the video. Yeah, so that's just a screenshot saying the same thing. So the video you just shows a massive step forward in our UI capabilities. And this was really important because we had to enable, if those of you saw Mauricio's talk just a little while ago, on this same framework, unfortunately I don't have any screenshots for this, we have layouts that look completely different for task management, for calendars, because it's completely customizable. And that's the whole point. We want to make sure that we have an integrated solution, a solution where everything's running at the same time. You're not having to do two different logins, go to two different apps. It's one system, but it customizes to what you're doing now, whether you are authoring, whether you're deploying, whether you're doing tasks, whether you're doing work. So what have we improved? So we've got rid of JCR and we moved to Git. And the reason why we're able to do this is because JGit is 100% Java. And the advantage of this means we've now got something that we know is scalable. Nothing gets more scalable than Git, end of story. We can now leverage all the abilities that Git gives us for multiple repositories, multiple projects, All our projects now are just Maven multi-modules. Projects can be shared. We can actually now have projects depending upon each other's projects, either to include model jars, or actually now we can merge knowledge bases. One knowledge base can include or inherit from another knowledge base. So you start to get a little more reuse, which has been missing before. And we built in a little local Maven repository management. And I know many companies will have their own centralized Maven system for deployment. The idea is that this is something to get you out of the box, maybe a staging ground, but because it's Maven, and it's just using Maven underneath, it can use the standard deploy to synchronize out to some central Maven repository. So, you know, you can either use the little local Maven tool, or you can ignore it. The other thing as well, that because it's Git, that means you can use standard team providers. So anyone within IntelliJ or from command line, instead of having to mess around with REST interfaces to be able to do your CRUD operations, it's Git now. So everyone can do CRUD operations from their language binding of choice. Every language out there has a binding to Git. Every development environment has Git capabilities. So it means now with Eclipse or IntelliJ, you can clone out a project or repository and work with that and sync it back up again, knowing it's something you're very comfortable with. This is what we have is a very simple POM editor. So we do have to be a little bit careful, because this, if people want to have a complex POM editor, they will go to Eclipse. We do want something that is comfortable for business analysts or technical business, what Gartner calls citizen developers. So underneath here is a POM, but we call it a project screen. We only show the version information, and this is the dependencies, so you can add model jars. And this is a much nicer way than having to upload a jar to a package, which is really some weird system. This is something that everyone can understand. So the system is now more intuitive. We don't have to do some weird explanations about what we do. If you want to know what we do what Maven does, therefore you know. I've just added two examples. You can either add them manually, or you can select them. So anything that's deployed into the local Maven repository, or is available via remote one, can be added manually, or you can edit the entries. Within here, everything can be built deployed. The toolbar and the menu bar is context sensitive. So depending upon which panel has the focus, depends upon which menu entries I've got here. So I think I have a little video which will demonstrate this. But in essence, because I'm in my project screen, the build deploy menu appears, and that's what actually puts into the Maven thing. So I do have a video, and it will show me changing the version number and deploying it into this very easily. Well, this might be it here. This is me 3 o'clock in the morning making this video, by the way. So I'm going to change I'm going to get a governor first, and see there's version 1. And remember, this has an HTTP here, so it's deployed and it's available to everyone. So there's HTTP or HTTPS, depending how you configure it. Change it to 1, I save it. Because it's Git at the backend, everything's got to be versioned. Saves that, it's made the POM changes, built it, deployed it, built successfully, saw the notifications there. I build it again just so you can see it. I go back to the Maven repository. There we go, you can see that's there now. So that is now published and public and available for your applications to consume. If you are using Fuse, Fuse Fabric now has the ability to do automatic deployments of jars via automatic provisioning. So literally this kind of now fully integrates with Fuse for some very slick operational aspects. I mentioned before, so there's the little toolbar there. Again, see how that's changed depending upon what has the focus, depends upon which buttons here. Sometimes we're still working, we're beta version, so this is going to change. So actually, what's in that menu item there? There's 2 buttons there. The theme is all Twitter Bootstrap. So, how we improve deployments. Everything now, just our deployment unit is a Maven jar. And everyone said, well, duh, why did you do that in the first place? Was because we did this back in 2006. And actually, when it comes to rule-based systems, it was never quite clear how we should go about doing what we're doing, because our competitors weren't doing this. So there has been a learning process. And sometimes you do things just because it's quick. But given time, this is the direction we move to, and but I think everyone hopefully will really enjoy what we've done. It'll make their lives a lot easier. So all projects are just Maven projects now. All projects compile to jars. Jars are just installed in the local M2 repo, which is exposed by HTTP or HTTPS. but it can be deployed to external repos. There is a REST interface to automate those Maven aspects, the Maven install, the Maven build, the Maven deploy. There is a REST interface so you can automate this process. So between Git to automate your CRUD operations and REST to be able to automate the operational aspects of that, you've got a really nice way of doing deployment. We have deprecated the CRUD REST APIs. One, because they didn't map, again, they had packages built into them, but actually, more importantly, I don't feel that, that it is necessary, because we have two things. We have, obviously, Git, the CRUD layer, but we also have what we call the VFS. So Java 7 has an interface called NIO2 VFS, Virtual File System. We backported that interface, and that is what we use to interact with Git from Java. So in Java, we have a standard Java 7 library for virtual file systems, which we backported to JDK 6, just to copy and paste and change the namespace. So that's the NIO2 interface of VFS. So that is, if people say, what is your content interface for what we do in UberFire and Governor, it is actually NIO2 VFS. That is the standard that we have written to. The backends are pluggable. If we didn't want to get to, we wanted to do, if we needed to do a JCR, it would be possible because of the VFS, because of the leveraging of the NIO2 VFS API, we can do multiple implementations. But I'm reluctant to do so because I feel that Git will allow us to expose a lot of powerful workflow systems. And if we start trying to bring in other backends like JCR, that becomes very difficult because you can't normally synchronize across all of them. Yeah, it's just Maven, so it's something that everyone understands. So utilization, how we use things. This is probably the biggest change. We have moved away from programmatic imperative to convention oriented and discovery oriented. We've introduced something called the KModule XML. This is an important file that needs to be in every jar that you build. This, even if it's empty, it must be there because it's how we do discovery, it's how we find all the resources. So CDI does something similar. It is convention based. There's no programmatic, well, there is a programmatic API, but you don't need to use it. It's really there for tooling. We have what's called multiple name entities. This will make more sense in a minute. We have inheritance of resources. We have default for lazy people so that you don't have to do all this, but it's there if you need it. One of the things we spend a lot of time doing is making sure that this has an out-of-the-box capabilities so that people don't have to learn too much, it just works. But there's more power there, more flexibility that they can move into if they want to later on. And this will become very obvious in a minute. And obviously versioning is now built as standard. You could do side-by-side versioning, but it wasn't built into how we're doing. So side-by-side versioning is now built in from end to end to how you build on a governor, to how you deploy, to how you consume, to how you utilize. So versioning is built in throughout. Free from Maven because obviously it's part of the Maven methodology. So I'm going to take you through some examples. You can go to GitHub yourself. There's the URL. These are the projects, and these are all little mini examples that show you how to use the UAPI. They are not about how to write rules, although there's a small rule example there. This is about how you write, how you utilize the API. And it starts off from something very, very basic up to something quite complicated, but it's layered. You don't have to ever touch the complicated aspects if you don't want to. But we need something to go from out of the box, don't want to know anything, up to incremental compilation for tooling integration. So this is an empty KModule. So all you have to do is just put one of those in your system and you're ready to go. If you have this, all you need to do is that. That's all you have to do now to run a program. This will find all BPM2s, all DRL files. It will find everything in that jar, everything in that project space. And it will build everything it finds into a knowledge base. So you no longer have to list all your resources. But only that, you no longer have to build a knowledge base. You can basically just say, you just have the idea of a container, because we do need to have some way of accessing the jar. The container is basically a reference to your jar, to your module, to your project. And when we do new KIE session, that says get me my default session, because when you do this, you have a default knowledge base and a default session. You don't have to instantiate the knowledge base first though. This will do this automatically, because when you think about it, if I'm instantiating a session, then I know I need to instantiate a knowledge base. So it just does it for you. So all I have to do is this, get my session, and and I'm ready to go. I do not collect my resources, I don't have to build knowledge bases, I don't have to do anything. Here's a little example. So this is one of the examples that you can run. I'll talk you through it. So default KIE session is this one. It's an empty K module. There's a message, there's a name and a text, so it's a person sending a message. There's the rules. That rule will print any message it receives. This rule says, hello Hal, do you read me Hal? So that's checking for that message. And there we go, Dave, hello Hal, do you read me Hal? So it's going to insert the message. That will capture the message and respond. And you can see here, I can't pause it because it'll just stop it, but you can see this is the test. So everyone here, all the examples are unit tested. This is me running the unit test. You can see the output there, the rules have responded. So it's very simple. This is now getting up a little bit increasingly complex because I might want to have a deployment that has different session configurations, different data. So this is the next level of complexity where I have a named K-base. So let's just say named K-base, not named K-session. So that's a named K-base and K-session 1. The name can be anything you want. By default, the package location of the resources matches the name of the K-base. So in your resources, it will find the folder that matches that and suck in all the resources. So again, you now have conventions to be able to find all the resources based upon the name of this. And based upon the name of this, you can now look it up. So you see here, instead of a new key session, by putting that there, we can now return back a named version. So it means I can have a project with multiple configurations of it, multiple automations, multiple sessions, and I can access any of those by a simple lookup. I have not had to specify anything. It's all convention orientated, all less code. It's the same example again, but this time it's just going to show you which one is it? Named key session. Almost identical. We can see there's a difference there. Oh, and I'm doing an includes one. So see this here? I can't really. It said includes. This project only has a rule 3 in it. I'm showing you the other project now, the named key session. So what's going to happen is that one project is depending upon another project and inheriting the resources. That's rule 1 and 2. That has rule 3. 2 different projects, 2 different deployments. And so this is just going to show you an example that this worked almost for free simply by adding that include attribute to the XML. So there was, I had to specify the Maven dependency. So Maven specifies the other projects as dependency, and now I can include that resources to get resource reuse. So this is a really powerful thing. I will put this keynote up on as a video, so you can get back and watch it later. But you can run these all yourself. They're very simple and very easy to understand. Again, a slightly more complicated game. This is actually now the code to the example you just saw. So key base inclusion, that's the tag you put there. So all you have to do is do that in your POM, which will specify another key project. And now I can reference the resources in it. And it basically just copies them all in. So this project now, this key base only specified rule 3. This one specifies rules 1 and 2. But the resulting K base has rules 1, 2, and 3. And again, to access it, all I have to do is key session 2, bam, I've got it. Because I've now got the 3 rules, it's like a little more complicated in the logic. Again, these all run, and they have unit tests, so you can see them running. This is getting more complicated again. I've just got a thing called Wampus, and I have moved that over to our K module. And this is showing that actually within the same K module, you can have as many knowledge bases as you want. Here I have a knowledge main, and I have the clients. But it's also showing as well that instead of having the default that it is loading resources from the package name that matches the name of the knowledge base, I'm telling it to ignore that, and instead load the ones that I specify here. So you have really quick, same defaults, but you have the ability to customize and have the flexibility you need to deliver what you want. And again, all I have to do is I look at my key container. See up there, it says ClassPath key container. This is quite important, you're going to see this in a second. Obviously, you have a ClassPath. That is all the jars on your system. What is on your ClassPath is on your ClassPath, and there's no controlling the versions of that. And actually, And like any class path, you can't have mixing and matching of versions. And Maven will only let you deploy one version of a jar there. So that's why it says key class path container. And it will basically index all the jars you can find. So those K modules, let's say you had 10 jars on your class path. It will find those 10 jars and index all the K modules, so all their resources are all lookupable like this, without you having to do anything. But it gets better. Can it really get better than this? Yes, it can. And a bit of coffee as well. I apologise, this isn't probably the most fun talk, but I'm hoping it's useful. It's showing that we've fixed a lot of stuff. And for those who have done a lot of work with Drools, you'll probably find this useful. For those new to Drools, you're probably bored as hell. Where are we? Oh yeah, so dynamic modules. So what you saw there was everything's on the class path. We want to be able to do dynamic modules as well. So dynamic modules is simply the ability to load version jars dynamically at runtime. Be able to do side-by-side loading. I don't want to be constrained by the class path. What you can't do, once you have a particular jar on the class path though, you can no longer do dynamic versioning for that Maven release. Because it's just, it's just the way it works. You can't have once on the class path, you can't override it basically. So it's just a standard limitation of Java. Anyway, so what I'm doing here is showing an example where I'm loading a jar from the file system. So someone's put a jar in the file system wherever, and I'm getting the key repository. So this is a new one you haven't seen before. So the key repository is an in-memory service to resolve jars. And you can place jars in it, and that's what I'm doing here. I'm basically saying in the repository, place this jar, and that jar is now resolvable. Every jar must be built by Maven, and as such it will have a POM properties, which means simply by giving it the jar, we index it, we know its release ID, we know its group ID, we know its artifact, and we know its, more importantly, its version. So this will return a K module. So the K module is the memory representation of the jar that's now available for use. If I want to use that jar, and I can have as many versions of these as I want, so different versions, and I can have many different types of jars, I can simply say new key container, that's how I reference the jar, and the release ID. The release ID you know because obviously it's there, but actually the release ID, you can build those manually as well, which you'll see in a minute, because it gets even better. So, I get the key container and everything's as normal. So I've now dynamically loaded a jar from the class path. And here we go. So now we're getting into the real meat of the stuff. I can put a dependency called KIE CI. KIE CI basically embeds Maven. So we have embedded Maven. It's optional because not everyone wants this. And we can now use Maven for resolving at runtime our dynamic modules, using the Maven release IDs or the gaps that they use. So what I'm saying here is I would like the container for this particular group ID, this particular artifact ID, and this particular version. If KIE CI is there, it will resolve it in the same way that Maven does. And if you have settings.xml, it will resolve that from whatever central repository. And this is important because people often come and say, oh, how do I get Drools to work with this, and how do I get Drools to work like that, and how do I do this deployment, and how do I talk to different servers? And now we can just turn around and say, whatever you do in Maven, you can do with VRMS. And this is going to be in VRMS 6. So we have a very flexible system now. So you can set up all sorts of content distributions and different locations. And we made a big point of not having our own configuration files and making sure that we delegate to Maven, because if we use Maven, it will use the standard settings XML that Maven uses for finding other repositories. Once I have my dynamic module loaded dynamically, potentially pulled from a remote location, I can just then again use it as normal because it will have its K module, its information that we've indexed and made available. KIE CI also updates with a thing called KIE Scanner. If you remember earlier on, I said that the knowledge agent is no longer there because the knowledge agent works with packages. It wasn't really feasible to continue that forward. So we've added a simple thing called a KIE Scanner. And all KIE Scanner does is just gets Maven to poll. Maven every now and then will resolve its dependency graph. If that dependency graph has changed, we can actually automatically update the key container. So you haven't seen it, the key container says update to. So you might deploy at version 1.0 on the key container. You can either manually update it to a version by saying update to, and it will migrate you to that new version, or you can put Key Scanner on there, and Key Scanner at regular intervals will have Maven resolve the new dependency graph, pull in the jar, and update the key container to this. And again, the really nice thing about this is that it supports snapshots, latest and stables, and version ranges, all different ways in which you want to configure about what you do or what you don't update to at runtime. So we have a huge amount of flexibility here now and be able to cater to customers' requirements. And in Java environments, this might not sound that sexy, but if you compare this now to other BMS products, this is now so light years ahead that you can, this is in the BMS space, it's quite a game changer with regards to flexibility, ease of deployments, and just getting stuff done. When you go back to some other products, or even back to BMS 5, it will feel very cumbersome compared to this. So what I'm showing here is the key scanner. So again, the release ID. So I'm going through an example here. So I haven't slept, and this is probably about 5 AM now I put this slide together. So I get the release ID. The release ID is not on the machine. It will deploy it, but because this is a unit test, it's a copy from the unit test. There you go. So that unit test there, that's where this comes from. What I'm doing is I'm going to deploy that jar, and that jar is actually put onto the file system, because obviously we don't want we want Maven to discover it in the file system, because that's what the unit testing is testing, that Maven's able to discover this. So it writes it and basically deploys it. So that's deploying it into the Maven repository, not into our key repository. So this is just mechanisms to make Maven do what we want to do. And then get the key session, and it's worked. So we have dynamically deployed something into a remote Maven repository or wherever Maven wants that to go, and we resolve that with key container. Now what I want to do is update the version. So update the version, I've deployed it. This deploy here, this is Maven, this is not our API, this is embedded Maven API. So we're asking Maven to deploy it to its Maven repository wherever. So simulating deployment of a jar to a Maven repository anywhere in your company. And here we go, we start the key scanner. So you tell it the container, i.e. the jar that's going to continuously resolve. And quite simply, every time you call scan now, you obviously have this in a loop. Every time it polls around, it will get Maven to resolve the dependency graph. If that dependency graph has changed, the key container is updated, and you can see here, this is now working, and you've not had to do anything, it's updated automatically. So this is a replacement of the knowledge agent, far more flexible, far more powerful, far more standard for what we're most used to. We still have builder APIs, they're not gone. These builder APIs are probably slightly more complicated than the other ones. We've built them for tooling. And some people have complained and said, oh, the other ones were easier, why can't we go back to the other ones? And I said, well, 90% of people are not going to use this. 90% of people are going to be using the K modules, the declarative stuff. Especially as we have web-based editors. We need to make sure we have something that's flexible, because I want to have something that's suitable for tooling, without the tooling having to go to internal APIs or to go to internal classes. So it's only a slightly more, it has a few more layers to give us the abstractions necessary. But the result from this is we have something that gives us incremental compilation, which means you continuously change the information underneath it, or the rules or the classes, and it compiles, you can put anything in this. So this is your virtual file system. This is not just the building rules, it will build .java files, it will build .drls, it will produce a jar. That jar will have all the information that's in your project. And it will do this, whatever you put into that file system. So that's one of the reasons why we have this. And likewise, whatever changes, it will only rebuild those changes that are there. It has a sort of a change notification system. And it has an event listener system, so that when you have a tooling, you receive just the things that have changed, the new errors that have happened or the errors that have been removed from the fixing. So again, we're trying to build something that's working much nicer with tooling. Some people might use this, for instance, if they want to do runtime template generation. They're not doing standard jar deployment, they're doing bespoke runtime code generation, and then they might need to use something like this. And it's only a little bit more complicated than we had before. Oh, here we go. So this is a terrible screenshot. This is basically an editor for the KIE Module.xml. So in this you can add knowledge bases, and this will author the underlying XML for you, and this obviously goes in the UberFire project as a component. I'll talk you through it because you can't see any of the lines. So this is obviously adding, removing, renaming the K-bases, K-base element. Every K-base can have one or more sessions, and those sessions can be stateful or stateless, and there's a tab to switch between the two. And you can configure things, whereas before you had to do an API to configure things. We now have excellent attributes for identity or quality, equals behavior, for a stream or cloud mode, and likewise for, because that's configured on the knowledge base, and this is the session configuration, which is real-time or pseudo, and we might add more over time. So, but, you know, although there's XML there, at least within the web-based environment, you do not need to author XML. And we've tried to do something that it's easier for less technical people. I will say that the 6.0 release will not be quite as easy to use as we'd hoped. It's going to need a bit more polish, but I believe it'll be a lot better than what we have in 5. So it's a work in progress. So if you're not happy with some bits of it, we will fix it quickly for 6.1. So we have updated Spring as well. So Spring now, if you remember before, for those who use Drools Spring, a knowledge base would have to specify all the resources it was going to use before it could do anything. Now, our key session resolves directly against the, you know, I said the jars are all indexed for you. So you don't need to do anything now. You just basically, the same way which you do new key session with the name, you can do the same thing with Spring, and it will just bind the discovered knowledge session. And then this is just standard count. There's nothing special there, but this will, a DRL file that's discovered, the knowledge built with the K module can simply be bound to this, this is a REST service, out-of-the-box servicing. Actually, you combine the fact that we now deploy as a jar, and you have Fuse Fabric for automatic provisioning of sort of camel services, you have a really nice sort of integration story there. We acquired Fuse, by the way, if you didn't know. So that's why I talk about them. It's just to zoom into the XML that you've already seen. I'm actually very far behind. Yeah, I'm only halfway through. Yeah, it's just more of the camel stuff. Everyone knows. If you know camel, then you know what this is. Okay, so this is the other thing we've done that is new. Out of interest, who doesn't know what CDI is here? Does everyone know? I know it's some of this is quite new technology. Context and dependency injection. Does everyone know what that is here? Okay, cool. So what this allows is for things to be injected, so you don't have to instantiate themselves. And it's able to do that with an understanding of the scope of what the work is being done. We have made sure that we have a CDI extension that allows to inject the key services interface, the key container, the key base, key session, and status key sessions. And this is very easy to use. Remember I mentioned before that if you have defaults, where if you have nothing in the K module XML, then it's the default knowledge base and the default K session, and it's on the class path. Literally, all you need to do is that one line there, and that will inject a default container for you. You don't have to do anything else. If you want to, you can specify a release ID, and if key CDI is there on the class path, this will automatically resolve by Maven. So this is getting rid of even more code. This will literally find and discover and bind automatically a specific version of a key module. And you can have these, as many as you want, in a file. This is actually from a unit test. And all these things are in the one file. It's showing that it is the same group and artifact with different versions. I forget which way around this is. Sorry, yeah, it's KIE Base 1. So see that it's the same name, but that's version 1.0, that's version 1.1. So this is showing out of the box, side-by-side version management. And this is what I'm trying to get. Versioning is now built in from literally how you work at the programmatic layer, your program model, to how you deploy. The Maven gives that pervasively throughout. So this is a really nice program model now. It means you don't have to think about these things. No, so that's the Yeah, so that was the key container. This is binding the key base. So that's the default one. That's just the one it finds in the class path. And obviously different versions of each one. And then you can do the same thing for sessions. Again, you don't have to bind the knowledge base. If you bind the session, if you inject the session, it will resolve everything automatically for you behind the scenes. One of the nice things that CDI has done, because it's contextual, it's a get or create. If the session is already bound, it will actually reuse it to keep the same instance. It has this idea of scoping. Although there is the ability to force new instances if you want to. I forget what that is exactly. This is unit test, but you can either force new versions or allow it to do a get or create, which is a really nice aspect to it. And again, it's just to show that I can have side-by-side versioning of my session. So saying I want this name session and this release ID. If you didn't put the release ID on there, it would find the one from the class path. Okay, so that's optional. If you're using the default, it's on the class path and it has no name as a default, you literally don't need anything. That will resolve. So that's what I'm trying to say. We're trying to have something that is there for lazy people. It gets you out of the box working really, really quickly, but has the power and the flexibility to move up to later on. If you want to, you can stay at that and never have to learn anything more than that, and that will work for getting started with training and getting people understanding. But the flexibility and the power is there when you need it. Okay, so that's a lot of the lower end stuff. I'm going to now talk about some of the more features. We don't have a lot of features in 6. Our focus was on deployment, utilization, how things work, and on improving the UI. But one of the things we've added is scorecards. I'll just talk about it very briefly. So this is a web-based metaphor. You've seen technical DRL. On top of the technical DRL language, you can build all these ways of authoring declaratively different types of knowledge. And scorecards is one of these. And what scorecard allows you to do is to define what's called setup parameters and characteristics. The basic characteristics is a classification of a field. And in this case, we're saying, I'll read it out to you, we have a customer, and so the fact type is customer, and the customer age is the field we're looking at. So the customer and the customer's age is the field, its type, and we are classifying its range. Equals to between 1 and 40, between 40 and 60, and greater than equals to 60. We assign what's called a partial score. You can have as many of these characteristics as you want. What this does, and I think there's another page which shows you, yeah, so that shows you a much larger one with lots of different characteristics. And what this does actually is that given some data, it will produce both what's called a calculated score and what's called ranked reasoning codes. And this is used in the insurance industry, basically anyone that you have to make a decision whether someone's creditworthy or what their mortgage value is. Scorecards is pretty much the standard default way of doing this. We work with a standard called PML. So what this UI does, this actually generates PML. And then we turn the PML into DRL for execution. It is possible to actually not use the UI and to import PML from standard tools, but we've not yet exposed that, so that is still an internal feature as I've listed there. The calculated scores are quite simply a summation of all the partial scores. That is all the standard does. We will go beyond the standard and start to do things like score weighting. We will have more flexibility. So the standard is quite basic because it has to be a common denominator across everyone's scorecard products. But I think if you're in the insurance industry, if you're in the mortgage industry, if you're in the credit ratings industry, you're going to love this tool. These things cost a lot of money. Something else we have, this is getting more geeky now. This is getting more onto the knowledge, representation, and reason. This is the stuff that I love. But yeah, we'll see how I lose people. So VMS has something called truth maintenance in it. So every time I do a talk, I show a very simple example about how truth maintenance can be used to write better code. So what I'm going to do, because maybe even if you use Drools, you probably might not remember truth maintenance, so we'll go back and go over the example I do, and I will talk about how we've extended it. So Drools 5 is what's called simple logical insertions, TMS, truth maintenance systems like Clips, JS, and others. This is an experimental feature. I'm not sure whether we may have a prototype. It's still being decided for BMS 6. Whereas all the other production systems, whether it's Drools 5, JS, Clips, or our commercial competitors, all pretty much work the same. As defined by Clips back in 1993, as defined by ART. With 6.0, we are introducing something called contradiction handling with justification-based truth maintenance system. This gives a clean separation of exception logic. And this is often a problem. In a rule, you want you want to respond to something, and then you have to list all the times where it doesn't respond to it. And that can become quite hard to maintain. So contradiction management is a way of doing this as a clean separation. The truth maintenance system there, what we've done is what's called, it has a pluggable belief system. So there's actually a whole range of things you can support by this. JTMS is just the first one of those. There's a next level up from this called defeasible logic. Defeasible logic gets a lot more complicated, but it is about the same thing, it's about exception management. I might want to say, because in general, all birds fly. Because that's good enough for most use cases. And then over time, and you might not know what the exceptions are, and then over time you'll say, well, no, a fat bird doesn't fly. A bird with a broken wing doesn't fly. A dodo doesn't fly. And you start to list the exceptions. But you can't put all those exceptions into the one rule. Because if I say, if a bird flies, you get 100 quid, I don't want to have to say, if a bird flies, you get 100 quid, and in the same rule, list all the exceptions. It's not maintainable, it's not, you just can't do it. So what defeasible logic does is an even more extended version to have a complete separation of these exceptions in a maintainable way. And it resolves what we call conflict management of those exceptions. It resolves those for you. There's a test there. You can see it working if you want to know more about it. So this is right at the heart of AI, knowledge representation and reasoning. They call it defeasible logic, but when we put this in BMS, we'll just call it exception logic. Otherwise, I think that's just going to scare the hell out of most people. So here's an example maybe you've seen before. This is about how not to write rules. It's quite funny. Just literally from 2 rules, you can do everything wrong. And people are like, how can that be wrong? This is a rule that I write over and over all the time. It's like, no, this is really bad. Rule 3. And the reason being is, what is it I'm doing? I've got 2 departments. One department is responsible for policy management. And I said, this is a toy example, please, don't take it too seriously. But one side is responsible for saying whether someone is an adult or a child. And that might change over time. And they will publish this. They don't decide how those policies are consumed, they simply decide the policy. Anyone below 16 is a child, anyone 16 or over is an adult. And what they do is they will have a spreadsheet, obviously much more complicated, of all these policies. And then you have the team which is responsible for issuing bus passes based upon this policy. They will receive the spreadsheet and they will code rules like this based upon the spreadsheet they receive that says anyone under 16 gets a child bus pass, 16 or over gets an adult bus pass. If the people decide to change the age range from 16 to 18, you have to author a spreadsheet again, send that out, and the bus pass people have to update all of this. But it's getting worse. What happens if you were in fraud management, if you were in other parts of finance, where often you're not allowed to know how decisions are made? You've exposed business logic here. The people issuing the bus pass only care whether you're an adult or child. The policy, that whether it's 16, 17 or 18, could be confidential. But you've exposed that to it now. So you've coupled the logic together. You've made it monolithic, you've made it whole, and you've leaked. You've leaked information because the bus pass people only care whether you're an adult or a child. They don't care how you know whether someone's an adult or a child. And they might legally might not be allowed to know. And then you have bad management. What happens when a person changes from age 15 to 16? So you have coupling of logic, you have leaking of logic, you have monolithic logic, you have rhythms of change, all within those 2 rules. That's pretty much what I just said. How can we improve this? We can use truth maintenance, as in Drools 5, to improve this. We use what's called inference or representation objects, an object which represents a decision, an object which represents a policy decision. So the people in the policy department, instead of writing spreadsheets and publishing those, they write rules. And they write facts which represent the application of those policies. So they simply say that anyone who is below 16 is a child. Anyone who is above 16, so 16 or above, is an adult. They don't say how this fact is consumed, they simply now have a fact that's semantic. This is quite important. We have something that semantically encapsulates that because this is quite simple. But imagine we are dealing with far more complicated policies. That is an expression, it means nothing. It's a number, it's an arbitrary number. If we were doing it in cats, that's not a child cat anymore now, that's a almost dead cat. So that's what I'm trying to say, that there's no semantic understanding. And obviously here it's very simple, you can, well I knew that was what it was, but imagine it gets more complicated. So you've lost potentially the understanding of what that is unless you're the domain person. And that's how mistakes happen as well. That's how mistakes happen. Oh, you know, I thought they were talking about aardvarks, they were talking about cats, and you know, they're all the same to me. What this does is it means that policy people have semantically captured the intent. It's not a magic expression, it could be anything, it is a child. There is no semantic ambiguity anymore now. So they issue, this is what they do, is they issue these rules. Now the people who issue the bus passes, they now consume results of this. So now we have encapsulation. They do not need to know how the decision was made if this adult was a child. They simply consume it. If this person is a child, based upon the policy rules, then we issue them with a bus pass. And vice versa if they're an adult. So they don't have exposure now. The information about how that decision was a child is not leaked. But more importantly, because we use that word logical, if a person changes from 15 to 16, the truth is no longer maintained, the object is automatically retracted from the system. So you don't have to delete it manually, it will actually be deleted. It will not, the system will not allow it to exist if the truth is not there to support it. So this is just showing that when the child, this will automatically, when the person moves from 15 to 16, the child bus pass will match this rule and send out a request to have a return. Something to think about as well, that all the people in the policy department now have to do is change their rules, and everyone else is decoupled from that change. This rule no longer has to change. The policy, I've got to go and update my rules, which means my turnaround time, my ability to adapt to businesses, to be able to give fast response times, is slowed down. This means I don't have to change anything. I'm there, day one, ready to go. So how do we improve that? Yeah, so this is, it decouples knowledge responsibilities, encapsulates knowledge, provides semantic abstractions for those encapsulations, and you've got robustness of change due to truth maintenance. What we have effectively is a chain of dependencies, logical dependencies. This rule logically inserts its child. Its existence depending upon that rule being true. We call it a plus because we're saying this is true. Obviously I'm getting onto the JTMS stuff now, so just explaining this is what Drools 5 does. Then the issue bus passes also logically inserts a child bus pass, because if the is child is removed, I have the support from it. This is called a supporting rule. The plus is the support that allows us to survive. If this rule stops being true, the support is gone, this is deleted. If that's gone, this rule is no longer has the support it needs. That's also made false, which means that's deleted. Now look at this. For whatever reason, I want to say, I don't care what, it's obviously a very simple example, whatever the reason is, we've decided this person is banned. Whether it's an adult, this is a child, we don't care, he's banned. And notice a little negation there. So it's the same fact. It's a child bus pass. All I did was add negation is negative fact. What I'm saying is this is not true. So I'm putting it in there. I'm saying, but this is not true. This is what we call a conflict. What will happen is, and if this rule fires first, that one, that issues the bus pass, the moment that The moment that this rule also fires, the child bus pass is retracted. But it's not lost. It will stay retracted while that is in conflict. So it will now say, and you can actually, it is possible to have rules to know that something's in conflict. I don't know if I've got an example of that, but you can know when a conflict happens, and then typically you will have a UI that says, these are my conflicts. This person is banned, I can't issue the bus pass. It's sitting here in sort of limbo until the conflict is resolved. And either you'll either go up further up the chain and correct the original problem, or you'll just leave it like that until eventually something corrects it. Or you might just override it and say, yeah, I know this said that he's banned, but actually I'm going to override that and remove that conflict. And what that does is it looks like this. It puts a negative on there. And it has a count. So you can have as many positive counts, as many positive supports, and as many negative supports as there are in the system. All you have to do is insert an object that is equal, the negation or not negation. And this allows us to have as many contradictions, whatever logic you want. And it's a very, very clean way to deal with what is just a hard problem. When you have to deal with exception management, there's exception management list on, but you want to have some same defaults. And this is how it starts. You don't know your problem domain, but you know it's, so you make an assumption and you write your system around this. You don't have to keep changing that because it's good enough for 80% of use cases. So using this contradiction management allows you to, over time, evolve your system to be able to handle contradictions in a clean manner and with separation of concerns without having to rewrite your core system all the time. So this is quite powerful stuff, and as you see, it's actually very easy to use.
Are we allowed those questions?
I think I'm almost, let me see where I am.
Mark?
Yes.
10 more minutes.
Okay. I've got time. I think this is the last bit. So this was actually introduced in 5. But I do this because, again, it's a little bit different. It's a technical thing I don't normally talk about. And because I finally got around to making an example, which I hope that everyone will be able to understand. So Drools is, historically, we have what's called a production system. It's a reactive-based system, very similar to database views and triggers. JRules is a production rule system, Jest is a production rule system, Clips is a production rule system. That's the type of rule engine we are. We have evolved beyond that though. We are what's called a hybrid reasoning system. So when you start to see what we're doing with the justification management system, when you start to see what we're doing with the backward chaining, when you start to see what we're doing, I haven't even talked about the event processing stuff, the stream, the complex event processing that we do. And we have a number of other research projects that do with academia, to do with probability and dealing with statistical rule-based reasoning. But they're very long-term research projects. But one aspect of what we call hybrid reasoning is backward chaining. And it's a very difficult thing to try and explain to people why it's useful. I'm going to have to sit down for this. Because it does a number of different things. But in essence, backward chaining is simply a query. But unlike SQL, it's a query that can be recursive. And it can give you some quite useful tools. So this is just one example, a very simple one. The child example we went through. Rather than inserting facts, I can actually have a query which represents results. So that is child there, doesn't need to be inserted. And that's quite important because if you have a large number of inferences, that can actually bloat out the memory of your system because you're having to eagerly cache all policy information, whether that information is used or not. So backward chaining allows me to have a query to encapsulate an inference, a policy, but it's done on demand, so it will only be resolved as and when it needs to. The downside is it takes a little bit longer, but if you have a very large number of these, there's a way of being able to scale the number of inferences you do. So, but where backward chaining really comes in is what's called graph-based reasoning or graph comprehension. And this comes from Prolog and Lisp. And it's very useful in sort of defect management. Manufacturing will do this because they'll have hierarchies of things. You have a car has a door, has a tyre, and they need to be able to look at the relationships of these things and be able to query them and understand what's going on. So there is real-world use cases to this. Often in companies, you will representative. You have the big boss, and he has his managers, and he has his teams, and they have an office, and they have computers. Everything in your company can be represented as a graph, and you can ask queries. The non-equinox queries can be reactive. So this is a very, very simple one. A graph that represents an office and a kitchen in a house. You've got a desk and a chair. And these are each individual facts, these are instances within my system. And I'm going to write one rule. Is contained in. And I want to be able to check if something is contained within something. So here's the query. That's the location. This is the location here. And I might want to say, is the lamp in the kitchen? Or I might want to say, what is it? Can you tell me what's in the kitchen? Or, and this is the other thing, we have what's called, when you're looking at graphs that go over a span, it's called a transitive closure. So what we're doing here, these queries are transitive closures. Our queries, our transitive closures are reactive. This is Prolog stuff, basically. But even Prolog does not do reactive transitive queries, i.e. it cannot tell you, if you want to know if something's changed, you have to rerun the whole query every time. We don't have to do that. We can find out on the fly if something's been satisfied without having to reevaluate the whole query. I'm going to show this to you in a minute. This will start to make sense. This is my last thing I need to show. Actually, I'll finish the slides first and I'll come back to that because otherwise I might run out of time. I already mentioned backward compatibility. We also have a JCR migration tool. It's command line and our consultants will be there to help you on that, so don't worry. There's the UberFire project. Uses Orion GWT, and that's how we built all the web stuff you've seen. This is a project you can use. Even the governor layer is now separate, so the Maven, the GIT, the virtual file system is completely separated from Drools and JPM. So you can build a workbench tool like that yourself out of the box rapidly. And as I say, UberFire is for compile time and composition. Everything's a plugin. Every single panel, every editor, every aspect is a Maven module that is brought together by composition. That architecture you saw earlier on, we do all that by Maven configuration. So we can recompile new platforms and new functionalities simply by changing our Maven configurations. It's lightweight, it's decoupled, blah, 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 blah. That's literally all the code you need to get a panel. That code there, when on the class path, will give you a panel that's automatically draggable and droppable and displayable as part of the Explorer thing. The proof is in the pudding of how powerful this platform is because we've rewritten our entire UI from the ground up in a 6-month period with a distributed team, and we managed to keep the code good. So I don't think many people would claim that. This slide I'm not going to do, I'm not going to have time. We've got a new algorithm that's beyond RETI, but it's grab me in the pub for that one. Let's see if this runs. Is my resolution? Yeah, resolution is too high. This will take 30 seconds and I'm finished. Oh, not 30 seconds, 2 minutes. Is that working now? I think so. Oh, I have to mirror them, do I? Or?
Yes.
Okay. Backward chaining, it's funny because people want to know what it is, and you explain transitive closures and graph comprehension, and then people kind of glaze over. So I've written a very small example that is hopefully easy for everyone to understand, and I'll commit this to the examples, and you've got to run it yourself. It has just one fact: location, and it has an item, and the location is where the item is located. And all I do is I insert those into the system. This is a representation of that graph you saw in that screenshot. People can't read that, can they? You sure? Yeah. I think IntelliJ lets you expand anyway. There we go. So that's what I'm doing. So I'm inserting those objects, and then I have go 1, go 2, go 3, go 4. Just to show you can see different types of rules we'll come to in a second. And this one's important here. That is the, notice that the key is not yet in the drawer. The key does not exist in the system. And then, where's the rules? Okay, so I have one rule, it's just this. I won't even need to run this because I've already run it before, I'll just talk you through it. So go one is simply saying, is the office contained in the house? Well, we know that we have, I'll just expand that. Yeah, there we go. We know that the office is in the house. So it will call the query, because that's what this does. This goes into there, goes up to here, passes the parameters in, and that matches, that will pattern match the house and the query. So that's fine, and you can see, almost done. You can see here, office is in the house. White, bigger is it? Anyway, down there it says the office is in the house. So go-to fires, actually, if you look at go-to, it inserts the key, it says insert go-to, nothing happens. Because go-to is the key in the office. There's no fact that is key and office. It doesn't exist. And what it will actually do is it will recurse, and it will then say, well, if there's no key in the office, what's in the office? And it'll go desk. It goes down the graph, and that's what this recursive process is here. Because it's what's called a transitive closure, reactive one. That graph now stays open. So the entire graph of all the different levels of is the key in the office, is the key in the desk, is the key in the drawer. That graph is open. And what happens is when you do this, when I insert that, that graph becomes satisfied. But that happens to reevaluate all of it, and it prints out the keys in the office. Now think about that, because we don't actually have a fact that says key office. That doesn't exist there. And we're not inserting the key office there, it's a key in the drawer. And yet from that information, it's being able to infer that the key is in the office. But it gets more. I'll just, you can have things bound and not bound. Thing is what's is unbound, so that will tell you everything that's in the office. If you go down here, go 3, it will tell you the drawer is in the office, the desk is in the office, the chair is in the office. Go down to go 4, everything is unbound, so this will tell you everything that's with everything, and you can see it's a big long list. It just goes down the whole tree, producing everything. So what this does is from one query, you can find just about everything else, everything that's contained within anything, and you can find out, you can set a monitor to see if something down below happens. So imagine you want to find out if a report 3 levels from you is failing. And you can set up queries to be able to do this now and get reactive monitoring based upon those. Or Maven dependencies are transitive. You want to be able to monitor those. Let's say there's a license violation. That transitive level could be any number of levels. You can set up a transitive query and it will monitor the entire graph for a violation in the Maven licensing. I think that's me finished.